The invention of transport refrigeration units in the 1940s changed our food consumption patterns forever. Suddenly, Florida oranges were available in snowy regions, and frozen food could be delivered far and wide. Previously, ice had been used to preserve perishables, so the trucks couldn't go far. Transport refrigeration units are designed for the long haul. When trucks are parked, they can be plugged into an electrical outlet to keep the cargo cool. Production starts with this computerized punch cutter. It cuts holes and slots in steel panels that will be used for the housing of the compressor and condenser. A worker then serves up the panels to a bending machine. It folds them so that they can be assembled to each other to form the refrigeration unit's housing. An automated machine bends copper pipe to form it into tubing for refrigerant. Each bend changes the direction of the pipe. It's an alternative to using fittings for this job. It means fewer seams, reducing the risk of leaks. A worker then joins the pipe to create the evaporator coil, in which liquid refrigerant is converted to gas to draw heat from the area to be cooled. Once the evaporator coil is complete and he's installed additional copper pipes for defrosting, a worker assembles it to the housing. The fan panel completes the evaporator. During operation, it will blow cool air into the truck trailer. The unit can be set to refrigerate or freeze depending on the trailer contents. A technician puts together the unit that goes on the outside of the truck. It compresses and then condenses the refrigerant during the cooling cycle. She secures the compressor and the copper pipes to the steel housing. She places a motor in the housing beside the compressor. Using a rubber belt, the technician links the motor pulley to the compressor pulley. She completes the connections for the inlet and outlet pipes. The condenser is next. It transforms refrigerant vapor back to liquid. Using more copper pipe, the technician links the condenser to the compressor. She connects a pipe to a little steel vessel that will hold liquid refrigerant not in circulation. The technician installs a filter unit on the outside wall and links the refrigerant pipe network to it. The mesh filter inside will catch dirt in the refrigerant gas and will trap any lingering humidity. Back to the compressor now, the technician installs a second motor. This one will keep the refrigeration system working even when the truck is shut off. All the trucker will need to do is plug the power cable into an electrical outlet. She attaches a pressure sensor to the pipe. The technician melts metal filler into the joint, where the discharge pipe links to the condenser. This seals the connection. The electronics for the control panel are next. The technician screws the metal board that holds them to the housing. Then she makes all the electrical connections. Now a safety test. Another technician connects the compressor and condenser unit to a vacuum and activates it. It suctions out air in the system. He then injects nitrogen gas and traces of refrigerant. If the gas escapes, it will indicate a leak in the system. To find escaping gas, he uses a special leak detector. It sucks in tiny amounts of air and analyzes it for the refrigerant. This enables him to pinpoint exactly where any problem might be. Another technician powers up the unit and confirms that the control panel is working and that the compressor motors are fully operational. They fill the system with nitrogen gas. It's a temporary measure to protect it from oxidation during shipping. The on-site installer will replace the nitrogen with refrigerant. It has taken approximately an hour to manufacture this transport refrigeration unit. When it comes to keeping food chilled or frozen, it should deliver for many years to come.